of 12i squared. Wait, is this recording?
Yes.
Please call me yes.
Yes, okay. So this becomes 12, the sum from 1 to n of I squared, minus 2, sum from 1 to n of I. So that becomes 12, n plus 1, 2n plus 1 over 6, minus 2, n plus 1 over 2. And you can stop right there. Some people attempted to simplify it down, and I tried to look at what you got for your final answer. So even if this was right and your final answer wasn't, I should have taken a point off, though I admittedly think sometimes I was grading so fast I saw that and moved on. But yeah, there you go. Good?
Wait.
It simplifies very nicely.
It actually does simplify down really nicely. It simplifies down to
And my considerations.
n plus 1, 4, n plus 4. No. Or you could have it FOILed out. That is 4n cubed plus 5n squared plus n. What's up?
Why is that a number going on top of the 12? Why is that on top of the equation? Like, why is it 12 over here? Instead of like 12.
How do you rewrite the number 12 as a fraction? 12 over, so the 12 multiplies by top, the 1 multiplies by bottom. Yeah. If you multiply top and bottom both by 12, that is essentially multiplying by 1, not 12. Okay, then the proof by induction. We start with the first case where I mostly looked at your algebra. So I mostly graded your algebra. Though, you are trying to prove something is true. So the algebra really, while being important, the most important part is the structure and the presentation of this proof. Some people's presentations were not very clean, and some of them weren't even very logical. So while I graded your algebra, your presentation really needed to be cleaned up a little bit. We proved the n equals 1 case. It is important you prove that what the left side results in, the right side also results in the same thing. If you just plugged into one side and said 3, you're not proving anything, right? So we plug 1 into the left side, so we get this. We also plug 1 into the right side. So the left side simplifies down to 8 times 1 minus 5. The right side simplifies down to 1 times 4 minus 1. Both sides come out to 3. And so because the left side and the right side both result in 3 when 1 is plugged in, that proves that this formula works for the first case. So then we are going to assume that for some number k, plugging it into the left side, which is this, will also give you what you get when you plug it into the right side. So now we go for the n equals k plus 1 case. And while I know the way I present the work is not the only way to do it, I was a little bit surprised by how many people showed their work in a completely different way than I did in class. So it just kind of makes me wonder, who are you paying attention to that whole week? But the algebra was, for the most part, pretty good. A lot of people got full credit for these. So we start with the left side. The sum from 1 to k plus 1 of 8i minus 5. And then we're going to turn it into the right side, which hopefully is k plus 1, 4k plus 1 minus 1. So that becomes the sum from 1 to k of 8i minus 5, plus the k plus 1th term, which is 8k plus 1 minus 5. So because of our assumption, this gets replaced with k, 4k minus 1. And this simplifies down to 8k plus 3. And so you end up with 4k squared plus 7k plus 3. And that factors down to k plus 1, 4k plus 3. Of which 4k plus 3 can be rewritten as 4k plus 1 minus 1, which is exactly what the right side should be if k plus 1 was plugged in. So you get the k plus 1 case on the left does in fact become the k plus 1 case on the right, as long as this substitution is allowed, so it's conditional.
So we could stop at k plus 1 and 4k plus 3.
I was totally cool with that, yep. In fact, one of the things I was looking for was, did you correctly rewrite this as this? And I was really looking for that quadratic. That was the easiest thing for me to identify. If you got to that quadratic, then you probably did the right algebra. So I really used that as kind of a key thing to look for. And my eyes got drawn to that quadratic.
I'm thinking that maybe the Pythagorean theorem can be proved by induction.
By induction?
Yeah. Like if you predict the